everyone! Welcome back to integralcalc.com. Today we're going to be talking about using the disk and washer method to find the volume obtained by revolving a surface around an axis. And in this particular problem, we've been told that we're revolving the surface created between y equals x squared and x equals y squared. The surface created between those two curves, we're going to be revolving that around the x-axis, and they've asked us to find the volume created by that revolution. So I've gone ahead and graphed the two functions, and this is going to be the volume here, or the surface that we revolve around the x-axis, and we're going to be looking for the volume obtained by doing that. So we're going to be revolving here around the x-axis. I always like to draw an arrow around the axis about which that I'm revolving so I can remember and make sure that I don't do the wrong axis or something. So since we're revolving around the x-axis, we need to make sure that both of our functions are in terms of y. So notice here that we've got a function in terms of y and a function in terms of x. We need to change the second one so that it's in terms of y. If you're revolving around the y-axis, make sure that both of your functions are in terms of x before you move forward. So we've got the first function, which is y equals x squared, but the second function, x equals y squared, we should change into y equals something. So the way that we'll do that is by taking the square root of both sides, which is going to give us the square root of x equals y. So now we've got our two functions in terms of y equals x squared, and y equals the square root of x. And the way that I've graphed them here, this curve is y equals x squared. The upper curve here is y equals square root of x. So we've got our two curves graphed, and we've been asked to, again, revolve around the x-axis. The formula we're going to use to find the volume is this formula here that I've written down. And the first thing you'll notice is that you have limits of integration, right? You have a and b. And you're usually going to find a and b by setting the two equations equal to one another. In this case, I'll save us the time because it's basic algebra, but what you would do is essentially set the square root of x equal to x squared. You'd square both sides. I'll just end up doing it. You'll get x equals x to the fourth, and then you'll move everything to one side. So I'll get x to the fourth minus x, and then I can factor out an x and I can solve. So I'll get x cubed minus 1, and you can see that x is going to be equal to either 0 or 1. So we see pretty quickly here that we've got points of intersection here at 0 and also at 1. So these will be our two intersection points, and sometimes in a problem like this, you're given a range on which to revolve, and you can use that too. But in this case, they didn't give it to us, so we had to set them equal to each other, find the intersection points, and we know that those will be our limits of integration. So we can go ahead and start writing out our formula here. We'll get the volume is equal to the integral from 0 to 1. We've got pi here as part of our formula. Now when it comes to outer radius, what outer radius means is, remember that we are revolving around the x-axis, right? This axis here is the axis about which we're going to spin this surface. So we want to start from the axis about which we're revolving, and just go ahead and draw a line perpendicular to the axis up to through the surface and up to the upper function here, right? Y equals the square root of x is above y equals x squared. So draw a line through the surface all the way up to that. What we're going to do here, that line represents the outer radius, right? That's the farthest that the surface is ever going to be from the axis. So what we're going to do is essentially take the square root of x, right, which represents that outer radius, and we'll put that here into our equation for outer radius. For the inner radius, essentially what we're looking at there is from the axis up to the edge of the surface, right, before we go through the surface, right up to the edge of it. that will give us up to the line or the graph of x squared. So we go ahead and plug in x squared for the inner radius. And then of course we've got dx. So outer, inner, you just go ahead and plug those in. And then we can go ahead and simplify and solve here. So what we'll do is we'll get pi, when we apply that squared there, we'll get x minus pi, oh sorry, and this was squared here too. According to our formula, the outer radius is squared and the inner radius is squared, and I forgot to add that second squared term there. So now we'll get x to the fourth dx. All right, so we can go ahead and factor a pi out of our integral just to make things easier, but we'll get pi times the integral from 0 to 1 of x minus x to the fourth dx. And now we can go ahead and integrate. So volume will be equal to pi times, we'll add 1 to the exponent there and then divide by the new exponent, so 1/2 x squared minus 1/5 x to the fifth, and we'll be evaluating that on the range 0 to 1. So when we go ahead and plug in 1, of course we'll get 1/2 times 1 squared is just going to be 1, and again 1/5 times 1 to the fifth will just be 1/5. If we plugged in our lower limit of integration 0, we would just end up subtracting 0 and 0 again here, so that's all going to cancel. What we're left with is pi times 1/2 minus 1/5. If we find a common denominator here, right, we'll get 5/10 minus 2/10, right? We find a common denominator of 10, multiply, and our final answer, you can see 5/10 minus 2/10 is 3/10, so we'll get 3/10 pi, or you can just write it as, it's a little bit cleaner, 3 pi over 10. And that's it, that's our final answer. So that's the volume obtained by revolving this surface around the x-axis. So pretty simple, that's how you find it. I hope this video helped you guys, and I will see you in the next one.